Welcome to today's explainer. If you've ever found yourself wondering how the universe really operates down at the absolute microscopic, subatomic scale, well, you're in exactly the right place. Today, we're diving into a super dynamic event that literally changes how we think about the relationship between light and matter. And the best part, we're going to break the whole thing down purely through visual evidence.
So to get our heads in the game, I want you to picture a classic game of pool. Right, you've got your cue ball, you've got your target ball, and you've got the geometry of the collision. But let's shrink that pool table all the way down to the subatomic level. What actually happens when light plays billiards with matter? It sounds kind of like science fiction, doesn't it? How can something totally intangible, like a beam of light, physically smack into a solid particle? Well, it's definitely not fiction. It's a very real, incredibly kinetic interaction, and we're going to see exactly how it plays out.
Take a quick look at the big picture here. This is our complete subatomic billiards table. It's a single diagram mapping out this unbelievable split-second subatomic event. Now, I know it might look a little bit abstract right now. We've got wavy lines, solid spheres, dashed arrows all over the place, but don't worry about it. By the end of this explainer, you're going to be reading this thing like a professional physicist. You'll understand every single bounce and trajectory.
All right, let's kick things off with Phase 1, the subatomic players.
First up, we've got our cue ball, the incoming X-ray photon. Basically, it's a tiny packet of light energy, which is represented as this wavy purple line traveling straight through space. Now, it doesn't have mass in the way we normally think about it, but as we're about to see, it packs a massive punch as it comes speeding in out of the void.
And waiting quietly, right in the middle, is our target ball, the electron. Just a perfectly round, solid blue sphere representing a subatomic particle of matter. Before the crash, it's just sitting there, totally resting, completely unaware that it's directly in the unavoidable path of our incoming photon.
Which brings us to Phase 2, the incoming X-ray.
Notice the exact way the photon's energy is moving. It's a continuous purple line on a dead straight trajectory right toward that blue target. And pay really close attention to the shape of the wave itself. You see how those squiggles are super tightly bunched together? They're intensely compressed. In physics, this compact wave formation is a dead giveaway that the photon is in a massively high energy state. It's coming in fast, and it is bringing the heat.
And that sets up Phase 3, the point of impact.
Okay, this is where all that kinetic energy gets completely unleashed. Think about the crazy chronology happening in just a microscopic fraction of a second. Step 1, the high-speed approach of that tight wave. Step 2, the sudden, violent collision right where they meet. And Step 3, bam, the immediate scatter. Light is literally physically striking matter. We're witnessing an absolute instantaneous transfer of momentum.
Now for Phase 4, the scattered aftermath.
Just follow the new trajectories here. Our original resting electron, it's been physically knocked off its spot. It deflects sharply upward along that newly formed dashed path, officially becoming the scattered electron. And our photon cue ball, it doesn't just ghost through the matter. No way, it actually ricochets. It deflects downward, carving out a totally new solid path toward the bottom right.
Now, if you take away absolutely nothing else from this explainer, you've got to focus on this exact comparison. We are looking at the tightly wound incoming X-ray photon, and we're comparing it directly to the scattered X-ray photon. This is, without a doubt, the single most important piece of evidence we have.
Look at the dramatic, physical transformation of the wave itself. On the left side, before the crash, those waves are super tight, compact, just loaded with high energy. But on the right side, after the bounce, look how loose they are. They're visibly stretched out and elongated. This is a massive clue. It tells us that the collision fundamentally altered the photon. It lost a huge amount of energy. And where did that missing energy go? Well, it didn't just vanish, it was transferred directly into kinetic energy, literally knocking that blue electron onto its new path.
So when we pull back and look at the subatomic collision totally understood from start to finish, it's pretty amazing, right? From left to right, you see the whole story. The tightly coiled high-energy approach, the physical strike, the upward blast of the newly energized electron, and the downward ricochet of the depleted, stretched-out light wave. You just successfully decoded a highly advanced physics interaction using nothing but structural visual evidence.
And that leaves us with a seriously profound mystery to chew on. Think about what we just proved. If a so-called wave of light can act exactly like a physical cue ball, if it can literally strike a particle of matter, transfer its momentum, and knock it clean out of the way, then is light really just a wave, or is it something more? That right there is the fascinating, mind-bending mystery of particle-wave duality. I really hope you found this subatomic game of billiards as fun to learn about as I did to explain. Keep looking closely at the world around you, keep asking those big questions, and I'll catch you in the next explainer.